You can talk anytime.
Thank you, guys. Happy to be here. I'm from DBDAO. I'm also representing DeSci New York City, and I'll talk a little bit about that later on. So get excited for that as well. Oh, can you see it on this? Can the camera see it? I don't know. Maybe I stand up here and the camera sees it. Oh, I went out of tune. Thank you. Keeping him on his feet. Do the slides there or no? So the problem that I'm trying to solve here is that we have all this scientific data. We have these DeSci projects out there, and obviously science is backed by data and backed by computation and backed by experimentation. And one of the real goals in sort of what separates open science, where people are just sort of contributing their data online and making it open, and I think decentralized science is like the incentivization mechanisms that people have to earn impact certificates or earn USDC or earn credit or earn reputation by posting their data online, or by posting their papers online, or by posting, we can also do the Control P thing. Okay, so it was about what I was saying is open science differs from DeSci because we can create incentive mechanisms through crypto and through blockchain and through impact certificates. And so the problem that we're trying to set out to solve here is how do we incentivize people who don't necessarily know each other to work together on the blockchain to contribute data to scientific experiments, and then reward them for the contributions that they make to a data set. So I'll kind of walk through the thought process of how we do that and how that works. Just before I'd start, I just wanted to say a little bit more about myself. I just finished my Ph.D. at Stanford. I was studying computer science, and I wrote these 2 books. One is on regulating AI. You can buy them both on Amazon if you're interested. And one is on company formation, so basically how to start a company in the United States, like a crypto company specifically, and how to do it somewhat legally as possible. So I basically wrote up all the steps. I think this might be helpful for people who are in DeSci, especially in the United States. So the goals of DeSci for me is around accelerating science and making science go faster, and also creating sort of a GitHub for scientific data. And then the other goal is kind of having more rigor around how data is collected and analyzed. And this will sort of tie into why I thought creating a Web3 database for decentralized science projects would be really helpful to do it. And the other thing I think is important is creating a permissionless thing. So with a lot of Web 2 things, you need to fill out a form, and it's kind of complicated. But I think what's cool about crypto and cool about DeSci is anybody can engage with crypto. You don't need permission from anyone. It's just it's all part of the protocol. And I was thinking wouldn't it be cool if anyone could contribute to a DeSci project just by conducting the experiment themselves and not having to go through, be part of a university or part of a PI, be part of a lab group or something. So I'll give us I'll show you this is a demo of how it works, but then we'll go into who's using it and then how the protocol works. But this will just give you a very simple overview. So say we wanted to collect every butterfly in the world. That's a tricky problem because it's very distributed across countries, and it's not clear how we incentivize them or what the format of the data should be like. So this is DBDAO here, and I'll show you how it works. So the first thing we do when creating a data set is we define what we're trying to do. So we need to say like, okay, we're going to create a butterflies of the world data set. So then the next thing we need to do is we need to define the schema. So in order for it to be like a permissionless way for people to engage with this, we need to say like, in order to permissionlessly engage, you need to fill out these specific fields. So in this experiment, it is the species, and okay, so it's the species. So it's just one field you have to fill out. Now, what makes this so cool is that every row that's in this database here is actually not just like sitting on the server, it's actually living on the blockchain. So every time someone adds to the database, what's happening on the back end is it's minting an NFT that contains the JSON object for that row in the database, and then it's also storing it on IPFS. So you can see here we also have fields for the NFT. You can see it on Block Explorer, and you can see it on IPFS. So we define butterflies of the world here. So now from this, we create a form so that we can send this. So say we're part of like Butterfly DAO. We would take this form that we just created right here and send this out to all the people who are in our DAO. So when we fill out the monarch here, this is actually tied to our wallet address. So you've put in the word monarch, and then you press submit here, and this is tied to the wallet. This uses MetaMask to tie this data value to your wallet address. So now you can see this data point is on OpenSea. Right here, it's on OpenSea. So you could buy and sell this data point, which is really cool. Because maybe you had like a lot of data or like a health record. You can it's all on OpenSea, and it's just all living in your wallet. And you can see, you can also see it on Avalanche. So this is the transaction history. So you have provenance for every piece of data. And lastly, you can see it lives also, it lives on IPFS. I think maybe we skipped over it, but there's an IPFS link there too. Okay, so now we'll dig into like who's using it and why they're using it. Okay, so I think one of the very cool projects out there right now is called HairDAO. So they're looking into like hair loss and how like they're looking for drugs or different types of interventions to do these like large scale clinical trials. Now, what I think makes this so cool is like how competitive they can be with traditional science. So if you're in like traditional science or like a drug company, you need to pay like thousands of dollars for each person who's contributing to your data set. And I think HairDAO's insight was that, oh, there's all these Reddit communities with hundreds of thousands of members who are wanting to participate in a clinical trial or experimentation, or just are experimenting on themselves and have no ability to sort of compile that data. I mean, how many people here have, your foot hurts and you don't know why, so you test out 10 different things and you find out what works well for you and what doesn't work well for you. It would be nice if you could also just, as part of that experimentation process, compile that data into a common thing. And that was kind of their insight here. So currently HairDAO, they're testing out this new drug called RU58841. And so they built a patient portal on top of DBDAO to collect data from all their members who are part of their DAO. So here you can see you upload your genome file over here, and you talk about like the drug that you're taking, with a brand, the duration, how you applied it, the frequency, the dosage, the efficacy, and you can upload some pictures as well. But they have this whole patient portal that they built, And every time you you create a row on that patient, every time you create an entry in that patient portal, that entry lives in your wallet, which is very cool. Another one is who's building on top of it is Altaflora. So Altaflora is based in the UK, and they're like a traditional like Web 2 company, but they wanted to become like more Web 3, and they wanted to create a epilepsy DAO. So there's some like clinical trial. There's some people are looking on in the internet and finding that CBD, like basically like marijuana, helps to limit the amount of epileptic seizures that kids have. So parents have sort of empirically found this out. And they have this very cool patient portal, which sends people reminders and email updates. And what they're doing is they're swapping out their existing sort of database to the DBDAO backend, so they can take their existing Postgres and then automatically create NFTs from all the entries that are in their database, which is cool. So you can sort of, if someone is a traditional Web 2 company, they can easily transition over to a Web 3 company just by swapping out, making it a very simple change in their code. Okay, so each of these different portions really needs to be converted to have like a full infrastructure for DeSci. So we need like DeSci needs its own storage, and maybe we can do it with IPFS and Arweave. DeSci needs its own hosting abilities, and DeSci needs its own name service. And one thing that they didn't really have was like a database, so I thought that would be like a good place to help as well. So if we had like a Web3 database, you get a lot of benefits from it also. So I think the number one benefit that differentiates a Web3 database from like a traditional Web2 database is like the incentive mechanisms that can be part of it. So now, instead of a database just being like Twitter, where you tweet something and your data goes from your brain to Twitter's database, and now they own that and they monetize it. Here, when you think something and you tweet it or you submit it, that data now lives in your wallet, and you can monetize, and you can use any sort of other incentive mechanism you want to get people to contribute to it. It's not, they don't just have to contribute out of their own goodwill now. You're paying people to contribute data. And there's this idea of like negatively priced data. So like normally, if you want to store data, you have to pay money to store it every month. You might have to pay like Google or Amazon S3 like 0.001 cents per month per gigabyte. But they should really be paying you if you think about it, because you're giving them valuable information. They should be able to in some way monetize it and give you money back for the data that you produce. Another cool thing about a Web3 data, and that's kind of like what we're trying to do, is pay people for their data. Another cool thing is like with a Web3 database is like you have data permanence. So how many times have you been part of a lab, the server crashes, there's a transition in PhD students, all that data is lost for scientific knowledge. And I think this is like an important thing, because like there's probably a lot of scientific data that was hundreds of years old that is now gone, and the same thing's going to happen in 100 years unless we do something about it. So by building a database on top of Web3 technologies like IPFS and like the block, like Ethereum, we can ensure that that data will be around for as long as those types of systems will be around. Data composability is cool. Like right now, you can't really link between data sets very easily. But when you have a namespace that is completely general, you can go across it. You can link rows in different data sets forever. Data ownership, data privacy, so people can protect their data with their own keys. Identity, so you can tie where each piece of data is coming to an individual person or to an individual machine. So say down the road, you have a temperature sensor that is contributing data to a data set, and you later find out that it's been calibrated wrong or there's some other problem. Now you can just go back to where it came from on the wallet address who contributed and invalidate it. Okay, so once you have the data, how does it work? So like I said before, every row in the database is an NFT. So at the end of the day, you have a database full of, let's say, 100 different NFTs. And what makes this kind of cool is, say it's a row of 100 people's medical records. Maybe a pharmaceutical company or an insurance company will come along and say like, oh, this data is very, very valuable. We're going to pay for this 100 records, we're going to pay $1,000 for it. Then what we can do is once that data has been sold, we take a cut, but then we give the majority of the money back to the people that actually contributed the data. So the money people put in their records, the money comes in at the top, and then the people who get the data, who put the data in initially, get money out. And this is really cool because you can't just, can only not only just sell the data once, you can sell the data multiple times to multiple people. So people can have a steady flow of income for their data, which is cool. And then the other interesting thing about having like a database built out of NFTs is each piece of data is a token. So you can now apply any sort of DeFi mechanic, like lending or taking a loan out on a piece of data or selling your data. If you have an NFT that's valuable, you can sell that to someone else and then get money, and then now they own your NFT that's generating a consistent cash flow. So now you can start to apply financial principles to tokenize data, which is really interesting. Okay, so now we have a problem though. If when you put data into a data set, you get a percentage of the earnings from that data as it's created, what do you think is going to happen? Is people are going to just try and put in thousands and thousands of records and try and get 99% of the data that is in the data set, money that's created by the data set. So something's generating $1,000 a month. I'm going to try and put in 1 million records into it and get all of that money to myself. So how do we prevent that? We prevent it by having people stake a small amount of money when they contribute something to the data set. So when you put a row into the data set, the person who creates the data set, who we call the curator, says, in order to propose putting a row into the data set, you need to pay 50 cents. And if your row is accepted, you get your 50 cents back. But if your row is rejected, you get slashed and we get to keep your 50 cents. And if the curator who creates this rule is evil, then people will not contribute to the data set anymore because they'll look at the log history on chain and see like the curator has rejected the past 1,000 rows. I saw the piece of data. I'm not going to participate in this data set curation. But this is a way of preventing spam, basically, by having people pay a small fee and getting them to get that small fee back if their data is good. And if their data is bad, they just end up paying for contributing money to the data set. Thank you. Okay, so the curator is the person that is in charge of curating a data set. And so who is the curator? So the curator can be, the curator in our case is a multi-sig. And so that means on the other side of it is 10 people. A multi-sig can be many things. A multi-sig can be one person. A multi-sig could be a team of people. A multi-sig could be a DAO. But a multi-sig could also be an AI. So an AI could be in charge of determining what types of data is allowed or not allowed into the data set. We can also encrypt everything so all the data remains private on chain. And this is sort of how the business model works, is that we take a cut. The person who curates the data set gets the cut because they do a lot of work in making sure the data is high quality and validating it. And then the majority of it goes back to the people that actually contributed the data at the end of the day. I'd just like to take 2 seconds to pitch DeSci NYC. So we host DeSci NYC meetups once a month in New York City. You can follow us. We're a big fan of DeSci Tokyo and DeSci Japan. So thank you for having us here. And You guys are all welcome in New York. We started this. We get a good crowd. We're always looking to help other people, or if you're interested in integrating, send me a message on Telegram at go Michael. And here's all the info on this last page. And we have to do any moment for questions or anything?